In this video, we will explore considerations for optimizing crop growing conditions. Then we will look at different hydroponic systems. We begin by managing the greenhouse environment based on the crop we are growing. Both temperature and light levels greatly affect crop production. Understanding and maintaining the best temperature for a given crop is critical. When light levels are not ideal, supplemental lighting can be added to enhance growth and shorten crop production time, which may increase profitability. Ventilation brings in fresh air that replenishes the carbon dioxide that enhances photosynthesis and growth. Fresh air also lowers the relative humidity in the greenhouse, which reduces plant disease by keeping leaves dry and reducing infection by many common plant pathogens like botrytis and powdery mildew. When ventilation is not in use, fans can provide constant circulation of the air in the greenhouse. This promotes uniform growth and reduces disease by providing a more consistent growing environment and reducing cool, high humidity spots that foster disease. Good air circulation also improves plant transpiration, which improves the uptake and movement of nutrients in the plant. This is especially important with calcium, the lack of which causes tip burn in head lettuces and blossom end rot in tomatoes and peppers. Proper spacing of the crop within the hydroponic system will also improve air movement in and around the plants. The nutrient solution in the hydroponic system is critical to optimum plant growth. The water used must be of high quality and tested before production begins and at least yearly after that. Nutrient mixes should be designed for the specific crop. Meters and tools are used to monitor nutrients, water pH, and dissolved oxygen content, which are essential for nutrient uptake. Now, as we move into types of hydroponic systems, it's important to know the crop characteristics since that will guide you in the selection of the system and the space required for production. For example, leafy greens and herbs are very popular crops in hydroponic production. One of the most common production systems used for leafy greens or head lettuces is the nutrient film technique, or NFT system. This is a closed-loop recirculating system. The nutrient solution runs through covered troughs in which the plants grow. It consists of PVC troughs with fitted covers that have holes for the plants. There are a limited number of in-row spacing options in commercial NFT systems. This can be a relatively expensive system to purchase and install. To reduce cost, NFT systems can be created from PVC piping. However, because holes are cut for the plants in the top side of the pipe, it is more difficult to clean these troughs between crop rotations than commercially produced two-piece troughs. The NFT system requires a reservoir for the nutrient solution, a submersible pump that continually circulates solution through the troughs, and air stones to help aerate the water in the reservoir. The nutrient solution flowing through the troughs is generally sufficiently oxygenated for good root growth. The troughs are supported on a metal or wooden frame that allows some additional spacing as the plants grow. The arrangement of the supports can be very flexible depending on the amount of space available and the crop being grown. Another system that was developed from the tobacco transplant float bed system is now called deep water culture, or DWC. This system consists of styrofoam or plastic trays or insulation boards that float on the top of a lined pond filled with nutrient solution. Plant density is very flexible and is determined by the spacing of the holes in the trays or boards. Deep water culture systems can be very inexpensive to build and use. The water in the pond is circulated with submersible sump pumps. It is important to keep the surface of the pond covered with trays to reduce the growth of algae in the water. Various aeration techniques are important and necessary for increasing the oxygen levels in the water. The better the aeration of the nutrient solution, the better the plant growth. A deep water culture system is more stable than other hydroponic systems due to the large volume of nutrient water solution in the pond and is less impacted by adverse conditions like power outages or absences. However, a disadvantage of a deep water culture system is controlling the root zone temperature, since higher water temperatures contribute to root diseases in some crops, like spinach. Media systems are another type of growing system which includes several subtypes. The key common characteristic is crops are grown in some sort of container with substrate that allows the addition of the nutrient solution through a drip system. These systems may be recirculating or not depending on the substrate. Stacker systems are vertical growing media systems used in some commercial operations for head lettuces and herbs. These stacked styrofoam or plastic forms are filled with an inert substrate, commonly perlite. The plants are transplanted into these pockets. These systems are typically non-recirculating systems. The nutrient solution is added at the top of the stack system through drip irrigation tubes and drains through to the bottom of the stack. Production issues with these include gradients of nutrients and light availability from the top to the bottom of the stacker. LED strip lights between the stackers or regular rotation of the stackers can reduce the light effects. Tall crops like tomatoes and peppers or vining crops like cucumbers require a substantial root support system in addition to a trellis system to support shoot growth. Typically, these media systems use hard plastic buckets called beta buckets, or large plastic nursery containers filled with coarse pine bark or perlite substrate. Another type is the bag system, which may include actual 3 cubic foot bags of pine bark peat substrates laid flat on the floor or bench, or plastic-covered beds of this type of substrate. Large commercial operations tend to use rock wool slabs in a supported trough. Good air circulation is critical to good plant growth in these crops since foliage of the plants can be dense and tall. Typically, the plants are supported on a wire system and older leaves are removed to improve airflow. Vertical fans are common to get good air circulation through the entire crop canopy. This quick overview has discussed hydroponic growing systems in a greenhouse setup. Additionally, fully enclosed structures can also be used to grow crops hydroponically. These facilities are typically called Indoor Controlled Environment Agriculture, or CEA. Being indoors requires the use of lights. However, the production systems can be stacked in horizontal rows that can maximize the use of the indoor space. Generally, startup costs are much higher for indoor controlled environment agriculture systems than for greenhouse production, primarily due to the lighting costs. The lights typically create a significant heat load in the building as well, so good air conditioning and dehumidification systems are critical to creating an optimized growing environment. In the next video in this series, we will discuss the production and operations necessary to run your hydroponic growing facility.